Let's consider mixture problems next. So let's say Anita works at 2 jobs for 50 hours a week, one in the math lab at a rate of $8 per hour, and the other one pays her $9.50 per hour. In a week, she earned a total of $460. How many hours does she work at each job? So best way to start a problem like that is to get variables. So since we do not know the two number of hours at each of the jobs, let's call them M for how many hours she works at the math lab and N for how many hours she works at the nursing home. So what do we know then? Organize the information that you read here into a chart or a table, which will allow you to set up the equation. So we have a math job, nursing job, and total. We have pay rates, number of hours, and amount of money made. At math job, she earns $8 per hour. Nursing home job earns her $9.50 per hour. M is the number of hours at math job. N is the number of hours in the nursing home job for a total of 50. Total means addition, so M plus N is 50. $8 per hour, and if you're working M hours, then you're going to make 8 times M dollars for math job. $9.50 times the number of hours N gives you amount of money made from the nursing home job. Together, they add up to $460. So look what we have now. We have a system of equations. So you can either use process of elimination or you can use substitution, whichever method you prefer to solve that system. And so look what we have then. I'm multiplying the top equation by -8. So I'll have -8m minus 8n equals negative 50 times 8, which is 400. Add the two equations and create a third equation, which eliminates the variable m, and you have 1.5n equals 60. Divide both sides by 1.5, giving you 60 over 1.5 or 40. And so m plus 40 is 50, which gives you m is 10. What does that mean? 10 hours she works at her math job and 40 hours at the nursing home job. So organizing information in the chart will point out what the equations are, and then you can solve using the methods you've learned before. All right, pause the video here and do these on your own. Again, let's organize our information and get variables. So you have a theater that sold 550 tickets. Some were discounted for $6 each, and the remaining are full price tickets at $8. Total revenue is $4,050. How many of each type? So let's say D be the discounted tickets and F for full price tickets. Let's organize our information then. Discounted tickets are $6 a ticket. D tickets, so the amount of money you collected are 6 times D. Amount of money you collected from full price tickets, 8 times F. F is the number of full price tickets. And then the total number of tickets add up to 550, and the total revenue adds up to 4,050. So we have a system of equations, and now use any method to solve that system. Pause the video, complete it, and then check your answer. So multiply the top equation by -6. Add the two equations to create a third equation. So 2f equals 750. Divide by 2, which gives you f is 375. Solve for d, and that will give you d is 175 tickets. So you sold 175 discounted tickets and 375 full price tickets. All right, let's try another one. Do that on your own. Pause and see what you can do. So let's say V is the number of pounds of vanilla beans and H is the number of pounds of hazelnuts flavored beans. And again, organize the information like we've done before. And again, you can see the price per pound times number of pounds is the cost of that flavor. Same thing here, cost of the hazelnut flavor is $11 times H. Addition of the two number of pounds is 20. And the total cost together here is $5 $5.75 times the 20 pounds that you want to make. So let's take a look then. This is our system. Multiply top row by -4, add the 2 and solve for h. And that gives you that you should mix 15 pounds of the vanilla flavored beans and 5 pounds of the hazelnut flavored beans so that you can make 20 pounds that sell at $5.75 per pound. All right, try this next one on your own. Suppose that a truck's radiator is filled with 10 liters of 30% antifreeze solution. How much of the fluid must be drained and then replaced with pure antifreeze to get a 44% antifreeze solution? So pause the video here and see what you can do on your own. Assuming you have come back, let's take a look. So we're going to do it visually. So here's 10 liters which are at 30% antifreeze. And you can see that we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 liters. And in each liter, you have 3 little squares colored green, which represents antifreeze. So we have 30 out of the 100. So 30% antifreeze solution, 70% water. So what does it mean to drain and replace? So drain means what? You're going to remove the liquid out. And so if I remove 1 liter, it will be this whole strip because you're removing the mixture. If I remove another liter, it will look like this. And then after you drain it, what are you doing? You're replacing it with pure antifreeze. All right, so let's take a look. So here we have 1 liter drained. And if we replace that 1 liter with pure antifreeze, it will look something like that. Now what? What does that mean? Think about it. So remember, the 30%, that is our original. So this additional 7 boxes that we inherited, that's the new amount of antifreeze in the entire solution, because draining and replacing these 3 boxes just gave us what we had before. And so that means if we drain 1 liter, we got 7 extra percent, or now our solution is 37% antifreeze. Okay, what if you drain another liter and replace that with pure antifreeze? Well, what does that happen? That means you got 7 more boxes, and so a total of 14, because all of these 6 boxes right here just made it 30% plus 7 from before, and these new 7s total 14 out of 30. So that means 44% antifreeze. So let's see that again. So we drained 1 liter, replaced with pure antifreeze. We got 1 liter pure antifreeze added, which just gave us 7 extra antifreeze percent. If you drain another liter, you got another 7 extra percent, which is a total of 44% antifreeze. And that's what we wanted, 44% antifreeze. So you have to drain 2 liters. All right, see if we can do this now using variables. All right, so let's say A is the number of liters to be drained and replaced with pure antifreeze. So organizing our information in the chart gives us original 30%. We have 10 liters, which means that number of liters of antifreeze is 0.30 times 10. You drain the 30% A amount because you're draining A liters, which means you're removing 0.30 A of antifreeze, and you're replacing it with 100% antifreeze, so which would be adding a 1.00 A. And resulting solution has to be 44% of 10 liters. So what does that mean? That means that 0.30 times 10 minus 0.30 A plus 1.00 A should equal 0.44 times 10. And then you solve for your A. And there you go. So they're saying that we should replace 2 liters of the solution. That's how you would do it algebraically. All right, so now you do the next few on your own for video log questions.